going to do here is talk about this line that's going through the data. We call it the line of best fit. It's also called the least squares regression line. Oh, there's a few other names out there as well. But the idea is if we have this data here, what is this line that goes through it? So visualizing this line just from having data and a ruler, what we want to do is kind of visualize this trend and have this line go through the data as best you can. So with my ruler, I might fit something kind of like this. And what we'll eventually do is have, of course, technology do this for us, because we want an exact line going through that does best fit our data. But for now, that works good. In visualizing this line, we're trying to be as close as we can to all of the points at once, which of course, like, I'm missing that point up there, but overall, I'm getting pretty close to everything. And that's what the least squares regression line's taking into account, is it's thinking about these distances away from each of the individual points and minimizing them. It's kind of taking this error into account and minimizing this distance away from the line. So these distances away from the line, that's called our residuals. So residuals are these vertical distances between each point and this line that we come out with. So what I could do is with each of these points is think about this vertical distance that's being created of how it departs from the line. There we have some distance there. And you can see in terms of measuring these distances, some have large residuals and some have small residuals. So like we have a little residual there, and here we have a big residual. But it's these distances that creating this line is trying to minimize all of those distances simultaneously. So the idea is it might have to leave this large distance, but overall it minimizes with the other distances. So calculating residuals, you always take the observed value minus the predicted value. And this gives you the distance away from the line. And we will see positive values coming through and negative values coming through. So these two wordings here, observed and predicted. Observed is always going to come from our actual data set, in that our observed values are each of the points on the scatter plot. Those were actual observed values from our airfare data. They actually recorded that they traveled that far and paid that much. So these are actual observed values. So those come from the actual data. And then you subtract, because we want a distance, and we're thinking vertically here, so you want to take that observed value, and what you subtract is the predicted value, which is going to be coming from the line. This line is a line of predictions. It's the idea that with this data, overall this is how we expect things to behave in the real world. So what this allows us to do is make predictions, so that if we decide to travel 1,000 miles away from Baltimore, we can predict how much we'd have to pay. Even though our observed might be a little different, this is our best prediction based on this linear data. So the predicted values come from the line. And since we're working vertically, it's using the y coordinates. So using the y values. The idea being we'd be looking at the same x value. So here, if we're at this x value right here, we could compare our data value, which has this certain output, and the output from the predicted line. And comparing the outputs is the idea of comparing the y values. So often with these, you have the same x value and compare the y's. So what this does is it describes the difference between what we expect and what actually happens. In terms of what we expect, that's coming from our prediction, and what actually happens is coming from what's observed. So, like I said, we're going to see positive and negative values coming out here. How we can see that up here is, well, if we're taking the subtraction, let's start where, what if our residual is 0? What if we subtract these two values and get 0 out? Well, if we get 0 out, that means these values have to be exactly the same. What we observed is the same as what's predicted. Or in terms of what we talked about, it would be that the point that we're seeing is exactly the same as the line. So it happens, if we have a point landing on the line, if we land on the line, we're going to see a residual equal to 0. If we land right on top there. And what this would mean is that this linear model at that moment is exact. That means it predicted exactly correctly based on what was actually observed. Then let's talk about these two regions. We have this region of values landing above the line and this region of values landing below the line. So if we are above the line, this is where if we go observed minus predicted, so we would take, let's go with this extreme example here, if we take this output, take the output or y value, which is going to be large, and then subtract the output from the line, which is going to be smaller. When we carry out this subtraction, we're going to get a positive value out. So it's here that we're seeing these positive residuals, positive distances, and it's going to be true for all of these. With these vertical distances above the line, we're always taking a large value minus a small. So up here we're seeing positive residuals. And what this means in terms of how our linear model is predicting things, it means the prediction that we're making is small. It kind of works opposite. You think positive means big, but if we're talking about how our linear model's behaving, it's behaving below what's actually happening. For all of these flights above the line, if we used our prediction first, it means everyone above this line paid more than what was predicted. So if we have positive residuals, this is where the linear model underestimates. The idea being that it underestimated what actually occurred. Because like for this person where it estimated that the cost should be close to $200 and they actually paid up to $400, they way underestimated what actually happened for them. Then when we're below the line, this is where if we take the y-coordinate from our point minus the y-coordinate from the line, we're taking something smaller and subtracting something larger, which means when we calculate these are going to have negative residuals. So we're going to get this distance out, but these distances are going to be negative if we're landing below here. And what's happening here in terms of our predictions and what the linear model is doing, it's that, say we're at this point here, and our prediction says, okay, you're going to have to pay about $150, but then we actually paid about $100. This is where the model overestimates. They estimated a higher value than what actually occurred. So the linear model overestimates here. So this is a way to describe the residuals. When we calculate the residuals, we get an idea of the distance away. And then from there, we can describe it as an underestimate or an overestimate by that amount based on is the residual positive or negative.